Hi class, I'm Jake,
I'm Tyler.
and today we are going to be describing to you Newton's laws in the game of hockey. Hey Tyler, how could physics just be so much easier?
I don't know, Jake. How could it be?
If the tree fell on Newton instead of the apple. Newton's first law states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force. This law is also referred to as the law of inertia. Now, if I have this ball here for demonstration purposes, if I don't apply any forces to it, it's going to stay where it is. But if I apply a large downward force to it, it accelerates that way. Now, we're going to show you this law in terms of hockey.
This diagram shows objects at rest stay at rest, and objects in motion stay in motion with the same speed and direction as long as the forces are balanced.
We'll be going over Newton's first law now. This puck here is obviously not in motion, but there are forces acting on it. There's gravity pushing it down and a normal force pushing it up. Those forces are equal, so it cancels, and therefore the puck is not in motion. However, if I stand up and I apply an unbalanced force to the puck, it will continue moving in a straight line until acted upon by another unbalanced force, like a net or the boards or a stick in the game of hockey.
Okay, so in the game of hockey, in the first law, I'm at rest. And I'll actually stay here at rest until I apply a force. Now when I apply a force, I start moving forward. And when I'm moving forward, I'm going to keep moving forward until, like in the game of hockey, a checker comes in and applies an unbalanced force, in which I will stop moving again. And since there is an unbalanced force, it changes everything. I'm not staying in motion anymore, and I'm not staying still. So anytime there's an unbalanced force, you either start moving or stop moving. Physics. As you can see here, according to Newton's first law, this also applies to the Zamboni. The Zamboni is going to stay at rest until Groovy applies an unbalanced force, which is going to be his foot pushing down on the pedal, causing the tires to move forward.
Newton's second law of motion. If it has a force on it from something else, then it will change its motion proportionally to that force. Now let's see it in terms of math.
When you're solving for the force, you multiply the mass times the acceleration. When you're solving for the mass, you divide force by acceleration. And you are solving for the acceleration, you divide the force by the mass.
Well, and according to the second law in hockey, first of all, this puck right here, this is a black puck. This black puck is what is used in professional hockey. It's much heavier than this puck right here, the blue puck. The blue puck is what's used for kids who are just starting to learn to skate and whatnot. And the blue puck is lighter so that they can learn to shoot and everything. And so in the second law states that force equals mass times the acceleration of an object. So as I show you, if I apply the exact same force to each of these pucks, then it should say that the blue puck will travel quicker. So if I shoot the black puck, it'll go that fast. And if I apply roughly the same amount of force to this puck, it should be going faster, according to Newton's second law, physics.
In the last example, we changed the mass. In this example, we're going to change the force we apply to the puck. So if I apply a lesser force, the acceleration should be less. If I apply a greater force to the same mass, the acceleration should be larger.
Lesser force, the acceleration should be less. The acceleration should be larger.
As shown in the last example with the pucks, since we know that the mass of both pucks was equal, we can tell the amount of force applied based on the acceleration. So, since the acceleration of the second shot was much larger, we should be able to tell that the force applied to it was also much larger, and vice versa, because they're inversely proportional. Physics! Also, according to Newton's second law, when we're skating, I'm going to apply a much lesser push, a much lesser force than Tyler will. And Tyler's going to apply a much larger force. So according to Newton's second law, I will have a lesser acceleration than Tyler, because the force and the acceleration are proportional to one another. So as we see here, I will apply a lesser force, and Tyler will apply a much larger force, and we'll see how fast it goes. That's physics, baby.
And lastly, Newton's third law. Newton's third law states that every action has an equal and an opposite reaction.
So, for example, let's say I decide to push my good friend Tyler here. Although it looks like I'm applying way more force to him, he's actually pushing back on me just as much as I pushed him. Physics.
Newton's third law is all over in the game of hockey. For the first example, just a normal hockey stance. My stick is pushing down on the ice, and the ice is pushing back up with an equal force on my stick. The same goes for my skates. My skates are pushing down on the ice with my body weight, and the ice is pushing back up on my skates.
The same thing applies to the hockey puck, and when I'm in motion. You see, gravity is always pushing down on this puck, and the ice is always pushing back up onto the puck with the exact same amount of force. That's also why, when I choose to skate, I'm pushing on the ice, and the ice is pushing back on me, and when I stop, I push on the ice, but there's so much pressure on the ice, sometimes it tends to fall apart. That's physics.
I simply love the game of hockey because of the fighting. Fighting also has a ton of physics in it, too. In a fight,
If I punch Tyler, although his face must hurt, so does my hand, because his face actually pushed back on my hand just as much as my hand pushed onto his face. Man, that rock solid jaw of his, that's physics, baby.